Hello guys, I hope you're doing well. Today we're going to learn how to solve second degree equations using the quadratic formula. So let's dive in. As always, most of mathematical courses start with a definition. So let's define what is a second degree equation. Let me put this into visible. So second degree equations are equations of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a different from 0. So to have a second degree equation, we must have a, b, and c as real numbers such as 1, 2, 3, minus 1, minus 2, minus 3, the square root of 2, pi for example, and we must have a different from 0. If a here is 0, then it's not a second degree equation anymore, it will be a first degree equation, bx plus c equals 0. So let's do an example. We have here 2x squared plus 5x plus 1 equals 0, and we want to determine what is a, what is b, and what is c. So can you guess it? As you can see, our a here is 2, our b here is 5, and our c is 1. So let's do some further examples. The first example is 4x squared plus 3x equals 0. Here we can see that a is 4, it's the coefficients beside the x squared, and b equals 3, which is beside x, and c equals 0 because we don't have here a number that doesn't come beside x or x squared. The second example is minus x squared plus 5x plus 1 equals 0. So here our a is minus 1. As you can see, we didn't write here minus 1x squared, we just write minus x squared. So our a is minus 1, our b is 5, and our c is 1. Sorry for this. Let's fix this. So our c is 1. Okay, so let's continue. And the last example is x squared minus 1 equals 0, which I want you to try and do it yourself. So now moving to solving second degree equations. So far we know that every second degree equation is written like ax squared plus bx plus c equals 0. There are many ways of solving second degree equations, but we are going to use the delta, the quadratic formula, and the proof of this method will be explained in another video if you are interested in the proof. So now let's learn about the delta. Delta is the name of the triangle in Greek, and to calculate it, as we said, we have our equations, our second degree equation a, b, and c are real numbers and a difference from 0. So our delta is b squared minus 4 times a times c. So our second degree equation is this. Our delta is b squared minus 4 times a times c. So we should learn this. Let's check some examples of calculating this delta and see why we should calculate it. So calculating delta, we take our first example, 4x squared plus 3x equals 0. Our a here is 4 as we said, our b is 3 and our c is 0. So we said that delta is b squared minus 4ac. Then our delta is 3 squared, which is our b squared, minus 4, and the factor here, times a here is 4, times c, and c here is 0. So our delta is 3 squared minus 4 times 4 times 0. So this gives us 0. Use this. So this is 0 and this is 9. So our delta is 9. Now moving to our second example, we have minus x squared plus 5x plus 1 equals 0. Our a here is minus 1, our b here is 5, and our c here is 1. So delta equals b squared minus 4 times e times c. Then our delta equals 5 squared minus 4 times minus 1, which is our a, times 1, which is our c. So this 5 squared is, guess this, it's 25 minus 4 minus 1, 4 times minus 1 times 1 is minus 4, and this is equal to 25 plus 4, which is 29. Good so far? I hope it's good. If not, try and stop the video and try to do it yourself. And now our last example is x squared minus 1 equals 0, which I hope you try and answer in the comments trying to calculate the delta. So now why do we calculate the delta? We calculate it to solve our equation, as you may think, but how? Well, that depends on the value of delta. In fact, generally, a second degree equation has two solutions. Let's call them x1 and x2. So every second degree equation has, in general, two solutions. Sometimes it's one, sometimes it doesn't have any solution, but in general it's two. So if x1 and x2 are our solution, then we may calculate them as x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. So now, before moving to how we calculate and the details, there is something everybody should know. So we found our solutions, x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. But before writing these two things, we need to check something that you should know and ask yourself every time you see them. Whenever you see a dominator, it should be different than 0. So here we have 2a in the denominator. This is denominator. So we have 2a here, which must be different from 0, which means our a must be different or different from 0, and that's what we said since the beginning. We said that every second degree equation is the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a different from 0. The second thing is, whenever you say a square root, what is inside should be positive. So if we have here x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a, then delta must be higher or equal to 0. And now let's continue. So now let's move to delta and calculating the solutions. Now our solution depends on delta. If delta is negative, the equation has no real solution. As we said, delta must be positive, either 0 or strictly higher to 0. If delta is positive, our solutions are strictly positive. Our solutions are x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. You see, here we have minus and here we have plus. Now if delta equals 0, we still can use the last two equations above and find x12, which is, we call, a double solution, equals minus b over 2a. How did we get that? We just made delta equals 0, then this term disappears, and we will have minus b, x1 equals minus b over 2a, and x2 as well equals minus b over 2a, which is only one solution. So moving to a recap of what we've seen so far. So we said that our equation is of the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a different from 0. We calculate delta equals b squared minus 4ac. If delta is negative, then the equation has no real solutions. If delta is higher than 0, then our solutions are x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. Now if delta equals 0, we still can use the two solutions above and find x12 equals minus b over 2a. Now let's move to some examples. Now let's take the equation x squared plus 3x plus 2 equals 0. We have our a equals 1, our b equals 3, and our c equals 2. What we do now, We calculate the delta. Delta equals b squared minus 4ac. So our delta is 3 squared minus 4 times 1 times 2. So this 3 squared is our b squared minus 4 times 1, which is our a, times 2, which is our c. So, sorry. So our delta is 9 minus 8, which is equal to 1. And as you can see, it's higher than 0. Then we have two solutions. X1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. So x1 is minus 3 minus the square root of 1 over 2, because b here is 3, delta is 1 over 2a, 2 we have 2 here, and a is 1. So x1 equals minus 3 minus the square root of 1 over 2, and x2 equals minus 3 plus the square root of 1 over 2. So the square root of 1 is 1, as you can see, or as you may know. Then minus 3 minus 1 gives us minus 4 over 2, which gives us minus 2. And x2 equals minus 2 over 2, because the square root of 1 is 1. Minus 3 plus 1 gives us minus 2, so it's minus 2 over 2, which is minus 1. Finally, if x squared plus 3x plus 2 is our equation, as you can see here, x squared plus 3x plus 2 equals 0, then our solutions are x equals minus 2 and x equals minus 1, which we can write as equals minus 1 minus 1. This is the set of our solutions. No, it's a notation. So I'll give you some extra. Since we found our solutions, we can write x squared plus 3x plus 2 equals x plus 1 factor of x plus 2. In general, if x1 and x2 are our solutions, then our equation ax squared plus bx plus c is equal to x minus x1 multiplied by x minus x2. Let's fix this. This should be a 2. Hence, finding solutions of the second degree equation is a method to factorize the polynomial. If you have an exercise about factorizing second degree polynomials, you may try and solve the equations, the second degree equation, to give you a factorization of your expression. One last example before the recap. Now we try to solve the equation x squared plus 2x plus 1 equals 0. First things we do, we calculate delta. So usually the first things we do is writing a, b, and c. Once you're used to it, you don't have to write them anymore. We move to calculating delta, which is b squared minus 4ac. This is equal to 2 squared minus 4 times 1 times 1, which is equal to 4. 2 squared is 4 minus 4, which gives us 0. How many solutions do we have? We have one solution. X12 equals minus b over 2a equals minus 2. Our b here is 2, so it's minus 2 over 2a. Our a here is 1, so it's minus 2 over 2. This gives us minus 1. So the only solution is x equals minus 1. If we want to factorize, we get x squared plus 2x plus 1 equals x plus 1 factor of x plus 1, which is the well-known equation x plus 1 squared equals x squared plus 2x plus 1. And this is the famous formula you have been memorizing. Now, one last thing before the recap. How do we know that we didn't make a mistake during our calculations? Well, it's easy. We just take our solutions. Here we have one solution and put it in the equation and see if it's right. In the last example, our solution was x equals minus 1. So we put it we put wherever we had x, we put minus 1, so this gives us minus 1 all squared plus 2 times minus 1 plus 1. This gives us 1 minus 2 plus 1 equals 0. So let's try, and this was our x squared plus 2x plus 1. We replace x by minus 1 in every term, and we get 1 minus 2 plus 1, which gives us 0, which we have been looking since the beginning. We have been looking for x that verifies this equation. And now we move to, so we are right. Now we move to the recap, and this is the last slide, so be careful. Even though we said that before in this presentation, we consider our equation ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a different from 0. We calculate our delta, which is b squared minus 4ac. If delta is negative, the equation has no real solutions. If delta is positive, our solutions are x1 equals minus b minus the square root of delta over 2a, and x2 equals minus b plus the square root of delta over 2a. And finally, if delta equals 0, the equation has one solution, x12 equals minus b over 2a. I hope you liked this video. I hope you enjoyed and you learned something, and hope we see each other in the next time. Thank you so much.